Thanks for joining. I'm Amber, an MLE at Arize. I'm going to be talking with Justin today about ML use cases, best practices, kind of his journey into the field of machine learning. Justin, thanks for joining us today. If you want to give a brief introduction.
Yeah, definitely. So very briefly, name's Justin. I'm currently a software / machine learning engineer at Google. Prior to that, I did a few years with Manifold. And then before that, I did a PhD in biophysics from Rice. So yeah, just happy to dive in and talk about, not just ML, but also how do you jump through these kinds of transitions.
Yeah, that's a great segue, Justin, because you've made several transitions over the past few years. Maybe just let's focus first on that first jump from academia to being a machine learning engineer. What were some key things for you for getting that first role?
Yeah, it's a great question. I think I tell this. I guess I could be brutally honest with how bad I was at finding a job first. Prior to doing the Insight fellowship with you, I tried to apply to jobs. I even these statistics. It's a terrible number. I basically applied to 100 jobs. I heard back from 5. I passed none of their interviews. And I think the challenge was really just knowing how best to showcase what you did have. I remember, in one of the first things we did at Insight was we did a really brutal resume review. I remember Matt at the time would just looked at us this is all pointless. I'm like, oh wow, okay, that's half the resume.
No CVs.
Yeah, no CVs. And also just learn to focus on what actually is useful in industry in a way, just knowing sort of what the industry is interested in. And so I shifted my resume from focusing a lot on this research problems I solved in my PhD that were fascinating but also not super relevant to a lot of jobs, and then more to sort of the actual mathematical methods I had to implement, the coding work I did, the groups I had to organize to do it. Those kinds of things started to it got a lot more traction. And of course, as you know, my success rate was a lot higher after that.
Right. Yeah. So definitely the resume review, what about key skills that you had to kind of develop for being a machine learning engineer from doing a position that's a lot of coding, but also a lot of research? How does your day-to-day change from kind of what you're doing there?
Yeah, no, it's good. Oh, yeah. So definitely, the resume gets you through the door, but to actually pass these interviews and sort of, actually do well at the job afterwards, you need the skills. And, I would say almost anyone who did a computational PhD almost certainly has the mathematical and the sort of, programming background that they could thrive. They just need to learn, the different ways of working in a way. So I had to learn, the hardest things for me to learn was working between meetings, having to actually produce code. And importantly, having to produce code with other people. This is actually a huge struggle for me. And I think it would probably be a struggle for a lot of people from academia, that I was very accustomed to coding by myself. I never had to go through a code review. And certainly not one where someone cared about readability. And, at first it was very hard to sort of have all these, what would feel like nitpicky suggestions, but to realize as time goes on that, oh no, this actually matters because, working in industry is this very collaborative process. You can't do any of this coding by yourself, all of it by yourself. You have to have other people, and being able to write code in a way and then communicate about it with other people is one of the most crucial skills I had to pick up to actually do well.
Right. Yeah, no, exactly. The collaborative part is one of the best parts of working in industry, and also one of the hardest parts as well. And so your first role was at Manifold AI. Can you tell us a bit about your job description and what your responsibilities were?
Yeah, so Manifold, it was a great company, and they did AI consulting. So they will work with and partner with other companies in the in various domains, and basically they'll implement entire AI workflow all the way from data prep, data ingestion, to deploying models, to monitoring models, everything. And for my job, it was a many hats role for sure. So I had to be a data engineer sometimes. I had to build dashboards, like a front end engineer sometimes even. Fortunately, not common because I wasn't a very good one. And then there's plenty of work as a machine learning engineer as well.
Right. Yeah. Many hats, especially with consulting ones. What were some of like the most interesting use cases that you worked on?
Yeah. Oh, so there's many use cases. I think the most interesting like problems I solved with Manifold would be when I got to actually do everything from end to end. Because I think it's actually rare now for a lot of machine learning engineers now that there's so many frameworks out there, but being able to get handed a pile of data, realize the data is not organized in a way that's easy to be ingested into models, and then designing a system that can ingest the data, process it, create features, and then train the model and learning how to monitor it. And I think like for me, it was also kind of nice to like work a lot in the healthcare space where there are interesting challenges with keeping the data safe. Because you routinely deal with PII and PHI. These are things that Manifold did a great job of sort of like siloing and protecting, and like working around those challenges also is like an interesting challenge where if you can't even dive into the data to see it yourself, like how can you solve the model, and then like finding ways around that.
Right. Yeah. So like and I mean, a lot of times larger teams can also be siloed from the different parts. And when you did finish like kind of the model experimentation, you're working through like which models to best use, like any advice for folks on like where do you start? If this is like your goal, like this is your use case, like where do you start actually building that model?
Oh yeah, it's a tough question because I think invariably when you talk to people who are outside the field, the things they've heard about would be image recognition. I've heard about this neural network thing, and I want to know like, can you build this brain that does everything for me? And like they have this huge ask. It's impossible, right? Like to do it, especially at a 3-month timetable. And oftentimes it's not even maybe the right place to start because if you've never even done, for example, linear regression, SVMs, like random forest, like these basic ML models, you don't even know if neural networks will help. You don't even know like how much lift that's giving you, because people want to jump to this really cool thing they heard, but oftentimes I found, not just in Manifold, but just in my personal projects, everything is that start with something basic, like get the data, get the overall pipeline built, from like end to end, and then like start with the basic model and see what's this baseline, like what can you get with just pure linear regression or pure like decision trees. And then you can start figuring out like, okay, like where is this model underperforming and how do I address that? And then you can slowly work your way up towards more complicated models then.
Yeah. Yeah. A lot of people conflate like simple with worse, when a lot of times like simple, like those very, straightforward, easy to understand algorithms are still incredibly powerful. And, if it's less expensive, faster, really just evaluating what you want from it at the end. And then, so once you do the experimentations, like you're reading the numbers, you're seeing like which models perform best, like you decide, what's going to be the main model, what might be some backup ones. How do you go about making sure it's ready for production?
Yeah, so many great questions, Amber. it's it's tough to know when something is truly ready for production, and I would say the biggest mistake I feel like I've ever made is like spending too much time trying to perfect and fine tune, like retrain models like over and over again. I think there's actually I think like what I found like to be a good strategy overall, and this is like pretty high level approach, and I think every problem needs a sort of that customization is find one or two metrics that are relevant to your problem, and you know have something, and like when you launch the model, compare it to what those metrics currently are with some baseline model. And this baseline model, if you don't have any ML, it could be just a simple like heuristic that you program, like some like threshold value on a number. And if it doesn't do better in those one or two metrics, you should go back to the drawing board. I've been in situations where we try to have 5 or 10 metrics, and we realize that it's impossible to make a decision when you have too many metrics to look at, because it will always do better in some and worse in others. So you
Yeah.
can't reduce a problem to the most relevant ones. That's when it's ready for launching.
That kind of like the paradox of choice, like too many choices, and it's hard to evaluate, and it's hard to like logically rank those as well, because the metrics themselves can be objective, but like who views what as best might be subjective. And I like what you said, Justin, about like, you're never really ready. Like you can never predict how models are going to perform in the wild, because no one knows what those inferences are going to look like. And that happened with a lot of models in production. Like during the pandemic, it threw off a lot of like expectations. And that's one thing we're looking to kind of combat here at Arize, like being able to set these monitors in production. Like you worked with like a lot of clients, like do you see folks doing like a different like build versus buy options? Like any advice for folks that are trying to monitor these models themselves?
Yeah, it's tough to know if you should build or buy. I mean, I think because there's so much uniqueness to everyone's problem and their particular constraints, like for example, if you say like, I want everything to run on premises, that knocks out a ton of buy options, for example.
Yeah.
Or if you do something like, I have a very particular problem. I can't find anyone who does this exact thing. You have to build it yourself. And most people are going to be somewhere in between, where they can probably buy some things, like, if they're okay with putting things in the cloud, AWS, Google Cloud, Microsoft, there's tons of options for like hosting services and, outsourcing that. But I will almost say, like, if you want to be good at ML, you almost have to build it yourself. Like, you have to have people on your team that can build these models. And almost always there's going to be customizations, even if you do buy. Like, there's going to be customizations to your model, tweaking of how you monitor, or what is really important for you, that you need to partner with like someone, or like hire or partner with someone who is like an expert enough to like help you make those customizations.
Right. Yeah. I think it's always like evaluating. I think there's sometimes managers that will say like, let's just build it all. But really kind of evaluating like your uses, what's important to you, KPIs, and then just going from there. And so you've recently made another new change. Can you tell us a bit about your new position and like what kind of the difference in responsibilities?
Yeah, after a while, I made a swap from Manifold to Google. It was, it wasn't really, I think I'm in this unusual situation where most people, they don't like their current job, or they don't like the people they work with. But I actually loved everyone I worked with at Manifold, everyone I worked with at Google. And, the main change for me has been, working on like different kinds of problems. So like Manifold was very concerned with building end-to-end models constantly for many different partners and clients. And then Google, I'm working on like one particular problem, and like this one like sub problem even. And Manifold has you have to wear many different hats. Everyone you work with has like slightly different tools that you have to like learn to reuse. I had to even do DevOps sometimes. And then like with Google, like when it's a more established company, I feel that you don't have to, you have to relearn their tools, but there's a well-established path for a lot of the basic DevOps or like setup. So
Yeah.
yeah, so like my work is so much more focused on just working on the ML part of things than on other parts.
Right. Because I mean, there's definitely like everyone needs consulting. Even, Google does consult with different teams. But it's probably very different in terms of like your day-to-day, like building something for someone else, trying to make sure everything is perfect versus building things internally. You might be able to like maybe iterate, make mistakes, and you can kind of see it through the lifetime. Is that what kind of like appealed to you of really trying out both? And would you recommend for people to try out maybe both options at some point?
Yeah. I mean, I think I think people who have never done a startup, I think there's a certain excitement that comes with having to like code by the seat of your pants that you just don't. I don't think you can get in a sort of like bigger company. And but I did want to try these things out, and I want to sort of grow, in other directions and try other things. And for me, like it's been great to be able to like focus on just one problem that I was particularly interested in, rather than trying to, do tons of other things.
Right. And so can you tell us a bit about like the kind of getting back into that interview process? Like, what was that like for you? Because I think a lot of people, might be afraid of transitioning roles just because, you have to go back and like relearn things. So how was that process for you?
Yeah, I mean, for me, it was, it was tough. Like I was fortunate that my wife was supportive, or at least she pushed me a lot to like, practice every day. So having to relearn how to do whiteboarding coding problems, for example, that took a lot of practice, and also having to relearn my basic interview skills of how to answer a question, how to talk to people that I haven't been talking to for like years. It was very scary, but I think I think I approached it the same way I did the first time, is just step by step. So like focus on one thing first, get okay at that, focus on another thing, get okay with that, and then just keep iterating on improving all of these skills little by little. And eventually, like it even becomes fun to do some of these whiteboarding problems. You start to see like the basic building blocks, you start to see the logic about like going through this practice. So for me, it was enjoyable in the end, but very scary to start.
Yeah, enjoyability goes up like as confidence goes up a bit in like in what you're doing. And I'm just curious, like, are you still going to be working remotely, or are you going like in office and at Google?
Definitely going in office. I don't know. Like I know a lot of people fall on different spectrums. Like some people like full remote, some people like in the office. I think I prefer something like kind of in the middle, where it's been fun to be able to like code and then just look at someone else's screen without having to like start a meeting, for example, and like be able to like actually use a physical whiteboard to like lay out designs, and that's just such a faster process to do. I have no idea why people haven't found a way to do it online yet, but if they ever do, I think they're going to make a ton of money. And but yeah, but at the same time, like it's also been nice to work remotely to actually just focus down and like code. Like sometimes it's nice to just have 8 hours you can just grind away on like writing this code. So yeah, it's been a hard transition, I say.
Mm-hmm. Right. Yeah, I mean, like definitely benefits and like disadvantages like for both options, but yeah, being able to like kind of strategize in the same place can definitely be helpful when like trying to come up with a solution.
Mhm.
So I really like consulting projects because you see like such a variety. Well, like, can you give us like an example of something that, may have been like really challenging, something like you weren't sure if it would work out or, how to go about it. But you ended up learning like a lot of interesting things from it. And, I don't know, it could have turned out great. It could have turned out terrible. Do you have any examples that you want to share?
Yeah, so can't go into details. A lot of these things are covered by NDAs. Unfortunately, it's one of the
Mhm.
hard things about academia versus industry is that people like to protect their discoveries. Industry, but academia, they made you talk about it everywhere you went.
Yeah.
But what I say is like, for example, like a general problem we might face, is uh, predicting like whether or not people will keep using a product or something like churn, basically.
Mhm.
And when you and like especially with Manifold as a consulting company, when you talk to these companies that you know they've never really been in the space before, where they try to track this, like with the machine, you know, step one, get like actually just like find a way to like measure that accurately. Like it's like prior to that, they might have a system where they might have some ideas, like they might have focus groups, they might have some numbers, but they maybe aren't doing like a live daily tracker even. And that's something that we can like we implement at Manifold. And then facing challenge of like where do you even start, because they hand you so much data that you know you can't possibly test all 100 features that they have. And credit to them for getting the data, but building a model of that is very hard. And so what we do then is, and I think people think ML is like you throw in the numbers, it'll work out, but it really works better if you find the subject matter experts that have already worked in the company and already have some idea about what keeps users happy and what makes users unhappy, and talk to them and like know like, hey, like what patterns have you noticed, or you're trying to sell this to people, like what happened, like when did people want to buy and when did people not want to buy. And once you like have those kind of subject matter experts, you can narrow down the focus to some set of features or something, and then from there the problem becomes way more tractable.
Right. Yeah, because it's definitely like a framing problem too, and how folks are thinking about it. Has there been any instances where like I mean, we talked about like putting models in production and like not being able to predict like what happens, but where like something in production, either the inference data or like the models start to drift, or like something happened and you didn't know what to do, you didn't know what to like where to start, like how you kind of tackled a situation like that?
Yeah, I mean, I guess like okay. So my biggest lesson from putting models in production is always put models in production on Monday, because there's always going to be things that come up, because like you said, you have no idea what is going to happen. You have no idea what kind of data is going to be thrown at your model. Like I remember, and like there are instances where you test the models in this test environment. um, and I think like it's good to have this test environment because you can catch a ton of things by having this sort of like like pre-pipeline that replicates reality as closely as possible, and you put it there. And the best thing about that is downstream consumers are not affected if something goes wrong. If some upstream data comes in that's weird, you can catch it. But then eventually, even if you do put it into production and you monitor for a while, some assumptions going to be broken. Like someone might tell you that, hey, like I expect X number of people to be like updated every day, or X number of users to be interacting. What happens if suddenly 100x like comes in, and like someone, and just because like someone forgot to tell you that was going to happen that day, and then your model breaks, it might behave weirdly, and like you might not even know like what happened. So the key thing there is just monitoring and like checking regularly, and like having metrics and performance metrics on the data. So you say like, it's a very simple alarm to say like, hey, the amount of data increased by 10 or 100 times more than what we thought it should ever be. That should raise an alarm, and that should get people to, like at first order to just check and say, did anything weird happen? And I think, building those monitoring systems is like pretty key at that point.
Yes, I totally agree with putting the models in production on Monday. I think that's great practice. And yeah, I mean, models are inevitably going to fail silently. They're inevitably going to break because the world around us is changing. And one topic, we touched on before the interview was about fairness and bias and making sure like your models are performing correctly. I know it's not your team at Google, but it's a big topic, not just at Google, but many teams. Have you tried implementing anything on like fairness or bias, or like how do you approach it? Because it is a very like emerging area.
It's very, I would say it's like very new. Like in a way, we've reached the point where everyone knows what neural networks are, but people don't know. I don't think there's like a well-established path about how to prevent bias in your model. And the standard answer, just throwing more data at it, doesn't always work.
Right.
I think you need to focus on explainability. So, for example, I worked on a project at one point where I implemented, SHAP values, basically as a way to say like, it's not perfect, like no mathematical model is always going to be perfect, but, some are at least useful of like sort of finding like big biases at least and like slowly working those down, for example. And I think in order to really tackle it, you have to have a human in the loop who's actively looking for possible biases, actively trying methods to monitor and check for these things. Because like you said, like bias is something that absolutely fails silently. You will have no idea that it's happening unless you're trying to find it. And I think and even then you're going to miss some. So it's important to just, yeah.
Yeah. And for that situation, yeah, like, I mean, Arize is where we just released our bias tracing suite. And one thing that I just kind of noticed is bias is so subjective. So being able to like this, you might not see the same issue occur twice. And so being able to like set things up, you're saying, use different metrics, see, because I think probably the last thing we want to happen is that the customer tells you your model's biased.
No, that would be the worst. Yeah. And I like what you say about like, like bias itself is even subjective. And I think I guess like it's hinting at another problem that having just one human in the loop is not enough. Like having a diverse group of humans in the loop is way better, because people will just see the problem differently. They'll see different things that might occur to them. And having that kind of environment will always perform better than having just one person or having only a small effort in trying to identify bias.
Right. Awesome. And so just like one more question, we're getting close to time. I know you can't tell us, exactly like what you're doing in your new role, but I'm just curious, like what you're the most excited about and like what kind of problems you're hoping to solve.
Yeah, I mean, I could say the general problem. I mean, like it's not like a secret thing.
Mysterious, very
yeah.
secret.
I mean, there's papers written about it. It's like called hotword detection. So like being able to like identify speech, and like actively, and it's like an interesting problem about not just how you do it, but how do you do it on like efficiently on like small devices. And I think for me, the thing I'm most excited about with this particular problem is actually learning NLP, or like learning audio speech processing for the first, not for the first time actually. Remember my Insight project was audio processing, but being able to like work on these like sort of more advanced methods, and like in this environment where I get to just focus on this problem rather than trying to debug the DevOps these things is something I'm really happy to do.
Right. Yeah. It's always exciting to like really get a focus in on a new area, especially something emerging. I guess speech, it has been around for a little while, but I feel like computer vision over like the last 5 years, like has done a lot, and like speech is kind of like the hot topic now, and everything that's being done with like language models and picking up there. So thank you so much for joining today, Justin. It was great catching up, and I'm excited to see what you do at Google.
Definitely, it was a lot of fun talking. Thanks for having me.
Yeah. Awesome. Well, thanks everyone for joining. We're at time, but look out for an article that's going to come out from this interview, and we'll have the recording available for community members. Thanks. Enjoy your day, everyone. Bye.